Dear all, I'm pleased to welcome you to the webinar, The World's Most Flexible Cable-Bound Field Seismographs for 2D and 3D Exploration in Tough Environments, Summit X1. My name is Knut Hirsch and I'm your moderator today, but the main characters are our presenter, Wolfram Gödde, Senior Geophysicist and responsible for the business development of DMT Geo Instruments, and Jens Schweitzer, who's our product manager for the Summit Seismic Data Acquisition System. In our Summit X1 webinar, we share features, advantages, and benefits, technical insights, exemplary setup in the field, as well as field case example from across the world with you. Now, a few words about the course of the webinar. The webinar will be recorded while preserving your anonymity. Please be aware. We provide the link to the recording afterwards. You are invited and encouraged to ask questions. For organizational reasons, I will collect them via the chat and ask these questions on your behalf to the expert at the end of the webinar. If you would like us to contact you, please post your question into the chat window. Only we can see your entries and we get back to you at short notice. Due to strict protection rules, data protection rules, the participants and your potential chat entries are only visible to us. That's it so far. And Wolfram, please take over and give us your presentation about the Summit X1 system.
Yes, thank you, Knut. Ladies and gentlemen, a warm welcome also from my side to our presentation of the Summit X1 Seismic Data Acquisition System. Before I show you more about the features and the benefits and some case studies, please give me the chance to give you a very brief information about the company DMT. So DMT was founded with its structure, what it has today, in 1990. The technical roots are dating back for more than 150 years. The head office is in Essen, Germany. You see here the buildings. And we have subsidiary consulting and engineering companies worldwide. Regarding the geo instruments, we are working with local partners in different countries. DMT is part of the TÜV Nord group, and the scope of engineering performance includes the geo and industrial engineering, mining consulting, exploration and geotechnics, R&D projects, and the development and production of geo instruments, which are seismic systems for active seismic data acquisition, for passive seismic data acquisition, some seismic monitoring. We have a core scan, a digital core imaging system, gyroscope, a slim borehole scanner, and a DC resistivity IP measuring system, and an X-proved laser scanner. So what makes the Summit X1 so special? With a short conclusion, we can say its outstanding flexibility. You have no determined geophone distance, you have no fixed takeout, and it's lightweight and easy and fast setup in the field. Meanwhile, you get the data display in real time, so it's not a harvest system. The key factors to reach this benefits is a snap connector. We see here a remote unit. This is a digitizer. The remote unit is connected, or the geophone is connected to the remote unit, and the data is digitized in the remote unit. And this unit is connected with a snap connector. You can see here two needles or small spikes, and these are connected to a two-wired cable, and then the data is sent to a data collector and the recording station, a laptop or a PC. So this leads us to a more detailed description about the individual components. So we started with a data collector, and we have the battery, power supply, Ethernet cable to connect to a laptop. The line cable we can connect to one line port of the data collector. We have also a second line port at the other side. Then we connect the remote unit to the line cable, a geophone, trigger adapter cable with a trigger extension cable, and to the seismic source. As a convenient alternative, we can also use a trigger unit. which can be connected directly to the line cable and then to the seismic source. So in this case, you avoid to carry the trigger extension cable with the reel in the fields. You just have to carry this trigger unit, which weighs 170 grams, and a short cable which connected to the source. The remote unit is also supplied with energy from the data collector, so you don't need additional batteries for the remote unit. So how does it look like for a more complex 2D or even 3D configuration? We see in the next slide. So we start with the remote unit, the geophone, line cable, data collector, battery. Then we have the laptop and the trigger input with the source. Then we can connect on one side of the data collector. We can connect the line cable with the remote unit, which can be connected everywhere you want or everywhere where it's necessary. And you can connect up to 50 channels, up to 50 remote units, or a distance up to 330 meters. So these are the two conditions which serves for one segment. We call it segment for one connection to the line port. If you need more channels or longer distance, you can choose the other side of the data collector and connect your units there. And if you even need more channels and a longer distance, you add additional data collectors with additional remote units and line cable. The laptop and the trigger input for the source can be connected everywhere to each data collector. And now if we want to do a 3D configuration, we need a cross-line data collector. It is named here as a XDC box. So the difference between the XDC and the DC box is that the XDC has 4 line ports. So you use 2 line ports then to connect inside the line, and the other 2 to connect parallel lines, so that you then get your configuration for 3D survey. Let's have a look at some accessories of the system. I already mentioned the trigger unit. Here you see a comparison between the traditional trigger with the extension cable and the reel, and below we have the trigger unit. So when you do your shots, then after the shot you can move with the trigger unit along the line without carrying reel with extension cable. The trigger unit has also an LED, which gives you then, which lights up if the trigger is enabled. So this makes also communication in the field easier. So of course, for more complex configuration, we can also use radio triggers. Another accessory is the wireless bridge to overcome obstacles like rivers or roads. For the wireless bridge, we need 2 data collectors at each side of the obstacle, and these data collectors are connected with a Wi-Fi access point, and then this is connected with a directional antenna. The data collector has or every data collector has a GPS inside, which you need here also to synchronize the data. Between this one and this one, you need the one over the obstacle, you need the GPS clocking. GPS can of course also be used for other surveys. When we're talking about the continuous recording, then you need also the GPS to synchronize the data. So from a vertical slice point of view, here the basic package of the equipment. We have the data collector, laptop, and the source here for reflection seismic, and similar for the refraction seismic. And we also, of course, can do then like MASW with low frequency geophones, and for a roll along survey, you just disconnect then the units from the beginning and connect them to the end. The assignment of your active spread is done via the software. So let's have a look at some parameters, some technical parameters we have in the digitizer, in the remote unit. 32-bit analog digital output format. We have a sample rates from 8 milliseconds to 16 kilohertz, instantaneous dynamic range for 132 dB. The data telemetry is done by the two-wired cable with self-sealing coating. This is an important issue. So this yellow cable here, the material is not just plastic. It is a kind of, it's neoprene material which seals itself then when you disconnect the remote units. We have one line segment with 330 meter length or maximal 50 channels, which can be connected to one line port of a data collector. And the remote units, the power distribution comes to the remote units from the data collector, so that you don't need additional batteries for the remote units, or you save batteries in the field, because you only need one battery per segment to power the connected remote units. We have the snap connector, which gives us the flexibility, the no determined geophone distance. The remote units are placed directly aside the geophones. This means we just have a short distance of analog or short distance for the analog signal from the geophone to the digitizer. And this means we have less crosstalk, less interferences from analog noise. The allocation of the remote units are done automatically, so the software recognizes the hardware address of each unit at its appropriate position in the active spread. So you don't have to do it manually. You just mark your first station and your last station, and then the addresses are allocated automatically. Data transfer rate is up to 5 megabit per second per line port. And we have the provision for continuous data streaming for passive seismic applications like REMI or Nakamura. And all in all, it results in a unique flexibility, reduction of survey time and costs, higher efficiency. Meanwhile, we keep the real-time line check, so harvest system. And this is not just our opinion, so we also get some feedbacks from our clients, which I want to show you now. To clients' testimonials. The new Summit X1 system is lightweight and allows us to design and carry out flexible setups in very demanding environments. Since its incorporation to our pool of instruments, our field crews have achieved a reduction of 30% in acquisition times with respect to our older system. It is a game changer. And another one, compared to our older standard 24-channel system, the benefits of the Summit X1 were much less equipment and more than 50% lighter than older system. Data quality seems better than what we have seen with no electrical noise. Trigger system is much easier to use than previous seismic blasting systems. The above benefits allows operation with a smaller crew, less fatigue, higher productivity, and lower cost per channel. And regarding the weight, we see here a comparison between the previous generation Summit 2 Plus, which was already lighter than a configuration with 24 channels and spread cable. And here we see the numbers for configuration of 240 channels and 5-meter geophone spacing. And we see the weight, the previous generation is 576 kilogram. And with the new Summit X1, we reached 234 kilograms. So a little bit less than half of the weight. And how does it look in the field? So that we can see in this picture. So here we have the configuration for 240 channels and for a maximum line with up to 3,000 meter length. You see here 7 data collectors, and here we have 9 line cables with 330 meter length. The remote units are here in these yellow boxes, and these are the batteries. And all this equipment fits in one pickup car, in one station wagon car for 240 channels and maximum 200 meter long line. Some impressions from the field. So here you see the housing is protected via the IPI 67 norm against splash water, humidity, and also against dust. And we see here an interesting picture. This was a registration of a 3-component geophone, at this time still with 3 single 1-channel units, so that it looks like this. So you have a 3-component geophone with 3 units, each 1 channel each. But now we will release soon. We will in the couple of days, weeks. So it's already ready almost. 3-component unit which have the same size like the 1-channel units, only with different connectors, so that this is not necessary anymore. So here a picture of a 50-channel survey, 2 people carrying 50 channels. Many clients, they leave the geophone connected with a remote unit and also carrying the equipment and the remote unit and the geophone sometimes on this geophone hasp. And here you see survey 50 channels, 13 shot positions, and the time for setup was 20 minutes, the survey duration 25 minutes, and the packing 15 minutes. So the whole survey was done within 1 hour. Here's some examples of 3 shot gathers. You see the refracted wave and the surface waves. Source was a sledgehammer in this survey. And we are coming now to a bigger survey. So this was an investigation of 6 profiles. You see the yellow lines, which are the profiles. Total length was 10 kilometer, and the aim of this investigation was to detect fracture zones and weak zones around a power plant. So you see also geophone distance 2.5 meter, very high resolution was the aim of this survey. We had 517 channels in the field and 200 active channels. More than 4,000 shot points. And the job was done within 18 days, but we think it could be faster because this was the first time the crew was working with the Summit X1. As a source, they used a mini-whip, a vibro. You see here the vibro. And what we can do with the system, we can define every remote unit as an auxiliary channel. This auxiliary channel can then record the source wavelet, the source sweep, and then send it to every remote unit for cross-correlation, or you send the raw data to the laptop and cross-correlation can be done there. Another option is that once you record the source sweep and store it in your laptop, and once you start with the measurement, the source sweep is sent to every remote unit, and cross-correlation can be done then in every unit, so you don't need to send the source sweep after every shot then to the remote units. So measuring time is a little bit faster, but of course you need a good QC of quality control of your source sweep, because it should not deviate from each shot point. We see some data from this is a reflection from the geological point of view. We had here in the surface, we had the Miocene molasses sediments, and as basement there was a limestone, and we see here the reflection of the limestone. We see here a stacked section with the reflectors of a limestone. And the next one shows us a case study of continuous recording. It was a scientific project from the University of Leipzig, and they wanted to locate the activity of a so-called mufette, which are CO2 degassing areas in the underground. So they installed then the 3-component geophones. These are the yellow triangles. These are 3-component geophones. And then they used 3 data collector and got 4 segments. We see here data collector, and here one, and the master data collector is here with the recording laptop, and in total 4 segments. And then they let it for 24 hours listening or measuring, and got the result of a different distribution of the activities of the so-called mufette, or the CO2 degassing areas. So for the highlights. The summary, we have the outstanding flexibility due to the snap-on technology. We have a lightweight. The power supply and data transmission is done via the two-wired cable. The data display is in real time. We have a high data quality, less crosstalk due to the short distance from analog geophone to the digitizer, to the remote unit. And we have option for continuous recording. And I want to finish this presentation with client testimonials. Here we see two testimonials. The first one, I'm able to work on the field. Believe me or not, the Summit units are very comfortable. I only need 2 people maximum to get the job done. And I had yesterday a field campaign in the tunnel with the X1, and I'm glad to report that it worked like charm. And because it's always nice to have happy clients, please bear with me and be patient with me that I show you the last client testimonials. In all of the above criteria, DMT and the Summit X1 system rated highest or equal highest in GHD's evaluation. Price per channel for a high-resolution survey. The Summit X1 is more cost-effective than any other system available. Setup and field handling is very easy, flexible and fast. The pre- and post-sale support we have received from DMT and the Australian rep Geosensor has been outstanding. And the last one from Eva. We were looking for a lightweight, easy to transport and reliable, robust, high-resolution solution at a good price. While one may say this is impossible to get in one system, it is exactly what we have found with the Summit X1. The system saves us personal costs on site because of the ease for deployment and operation. There's absolutely nothing I can fault the Summit X1 system and support on. So thank you very much for your time, and please have also a look at our internet page, www.dmt-group.com, Products Geometering System Summit X1. You will find a movie there which was done by one of our clients, the Cordillera Geo Services in Austin, and he explained there how to do a reflection tomography survey. And I hope I can see you soon somewhere in reality. Unfortunately, now it's not possible. Take care, stay safe, and thank you.
Thank you, Wolfgang. This amazing presentation was very interesting. And the audience, you will get this presentation as a PDF file via an email quickly after this webinar. And now we get back to the question that came in during the webinar, and I start with a question from Mohammed. He asked, are the 330 meters max length including both sides of the DC?
No, 330 meter length is for one side. So both sides would be 660 then.
Okay, thank you, Wolfgang. Now a question from Anas. How about the resolution we can get? What is, for example, for a geological layer less than 2 meters thick and about 80 meters in depth?
Yeah, the resolution is always not just a question of the equipment. Of course, it's a question of the source of the frequency spectrum you get, and then it's a question if you want a vertical resolution or horizontal resolution. And yeah, but 80 meter depth, it depending on the geological condition, of course, also. But I would say maybe difficult to resolve 2 meter depths. Maybe you will resolve it in 20 meter, 30 meter, but I think. But it's just yeah, you have to consider the details of the condition, geological, or which source you are using, and to make them more detailed, or to get more detailed information than. Well.
Okay. Stefano asks, what software do you use or suggest for 3D data processing?
Yes, this is well, the format of the data is a SEC2, SEC-Y format, and you can use every commercial software. We have experienced and with our clients with Radex Pro for bigger survey, who use this software for 3D data processing. We have for the small scale software with ReflexV. For MISVW, we had a good experience with Swan from GeoStudio software. But yeah, these are some our experience, but you can use every kind of commercial software.
Okay. Another question from Paul. Is there protection against lightning strikes? Jens, du bist noch stumm geschaltet.
Of course, sorry. Yes, of course, we have a protection against the lightning events or also ground potential issues. So all of them are blocked inside the units and as well as also inside the DCs. So we will not have any damage through lightning.
Wonderful. And how does the cable system handle wet conditions? And do you have marsh or hydrophone options?
Yes, well, the system works in wet conditions. I can see we have now, from the previous generation also used the cable, so there's more than 25 years experience and projects in wet conditions. And we can use marsh geophones, of course. Hydrophones, I would say with 24 hydrophones in the borehole, it's not this is not the appropriate accessory for this one. But the rest, I would say yes. Mm-hmm.
You mentioned before that it's IP67 protected. Yeah. So it's protected against water coming inside. It's not for drowning underwater permanently, but just laying in the water is no problem.
Okay. What is the average number of channels for projects with Summit X1?
Well, our clients, they have, what they bought is in the range of 24 channels up to 1,000 channels. The main where we configure the system for 3,000 channels, but what we sold now, or the clients we support is from 24 to 1,000 channels. The main focus is from 24 to 300 channels. So these are the most of our client who are using most of the system for such an amount of channels.
Mm-hmm. Thank you. Another question from Mohammed. If multiple DCs are used, is the data automatically combined in one file, or do we need to do a data addition first?
No, it's automatically combined in one file. Then.
Okay. Another question from Emma. Does automatic allocation of the remote units requires a minimum cable length between two remote units?
Yes, there is a minimum cable length of 1 meter between two remote units to ensure that the order of the remote units can be preserved. Mm-hmm. 1 meter.
Okay, as far as I can see, I have all the questions asked so far. So the audience, please use the remaining time, to ask maybe one or another question. We wait for a minute or so. And in the meantime, again, a comment from my side, because the question appears here and there in the chat window, all of you will get the presentation afterwards in an email as a PDF file. And if you like, we share the recordings with you. So drop an email, your email address into the chat window, or just a hint. Please provide us with recordings and we will do so. And it was a real pleasure to have you here in these strange days. And for all of you, stay safe and healthy. And we get hopefully in touch physical.
Yes, hopefully.
Of course.
Thank you.
Yeah, thank you from my side for joining. See you next time. Bye-bye.
Bye. 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 Bye.